Okay. Testing. Testing.
Why is there fish on it?
Hey there, Geometry. For both Period 3 and Period 5, this is going to be a review for the final. Just a point that I want to point out, this is not a one-and-done review as in you watch this and you're prepared. No, you still need to study. You still should look at old tests. You still should practice problems, especially those textbook problems I gave you. Those are pretty useful. The point of this video is just simply to go through a little bit of everything, just so all the topics are covered, and to help us understand like what am I somewhat expecting to ask you. I'm not going to go over every type of question, but I'm going to make sure that we get to at least every topic. Whether I'll give you every question in that topic, maybe it's not likely, but this will get to at least every topic, at least one question from each topic. Now, on the review sheet, it should be from 7.5 to 7.7. The only reason I have 7.1 here is because it's the Pythagorean theorem. And we gotta use the Pythagorean theorem. It will be on the test. And the reason I'm going to put independent questions on it is simply because it helps you guys out. It's a very basic type of question. So you should be able to find the triangles with the Pythagorean theorem. So let's just start with 7.1 right here. I'm looking, the Pythagorean theorem, if you don't forget, is a squared plus b squared plus equals c squared. I will not be giving you that on the reference sheet. That would be a no way. You got to know what that is just by heart. So A and B always represents the legs of the right triangle. So this one and this one. So 5 squared plus 12 squared equals c squared. So 5 squared plus 12 squared equals c squared. Some of you might recognize this as a Pythagorean triple. If you don't, that's okay. 25 plus 144 equals c squared. 25 plus 144 is 169 equals c squared. At this point, you have to square root both sides. So your answer here is the square root of 169. This is a perfect square root. This is 13. It's multiple choice, so you know if you need to leave it as a square root or give me the actual number. Just remember that if there's a choice, you give me the actual number, which is 13, not just the square root of 169. But it's a multiple choice question, so you know which one is the better one. We got here 7.5 to 7.6. The reason I combine these together, it's 7.5 is tangent, and 7.6 is sine and cosine. So I'm just going to do both together as one subject, just because it works better like that, honestly. So 7.5 to 7.6. The basics of this is, one, you definitely need your calculator, and as I mentioned in class, you're forced to bring your calculator, or you need to bring a calculator to school. The school will be not providing any calculators at all. So let's do some SOHCAHTOA quickly, and then I'll go to 7.7, which is the inverse. Just remember, it depends based off the angle you're talking about. First, it's always a right triangle, and it's some angle. This symbol is called theta right here. So we always got to base it off theta. So opposite of theta is this one. So this is opposite. Adjacent is the one next to it. And many of you guys asked when we were learning this, isn't this technically adjacent also? It technically is, but it has a more important name, which is the hypotenuse. So with that in mind, let's do some problems. These I could just make up on the fly. So let's say theta, I want to find 8, and I want to find this as x. So which one do I use? Well, I look at my SOHCAHTOA, which you should remember. I'm not giving you that. So is opposite hypotenuse. I don't have hypotenuse, so no. Adjacent over hypotenuse. I don't have the hypotenuse, so I'm forced to use TOA here, which is tangent. So tangent of theta, or I gotta give you theta equals, let's see, opposite over adjacent, which is 8 over x. A question could be just, please give me the fraction that equals 2. Another type of question could be, give me the actual answer. So I'll rewrite almost the same as that question, with this time I'll put 32 degrees, let's say. So 32 degrees. Compared to here where it's just theta, this would be your answer here. If I just told you, please give me the fraction, 8 over x. Over here, you have now an actual measurement. So now we're going to put tan of 32 equals 8 over x. Now, how am I going to get rid of x on both sides? I'm going to times x here, cross this out. Now I have, and I'm going to start writing over here just to make more space, x times tan of 37 or 32 equals 8. The problem with this is I don't want tan of 32 next to my x. I want x all by itself. So the only way I could do that, since it's multiplication, the opposite is division. So tan of 32, tan of 32. So I'm going to end up with x equals 8 over tan 32. And all you do is to slap that into your calculator. So let me just pull out the calculator here on my computer. So 8 divided by tan 32. Enter. It should be, and make sure your calculator is in degrees, by the way. If you're not sure how to do that, go to mode and then highlight degrees and press enter, and then you can quit out. And your answer should be 12.8. Your answer should be 12, x equals 12.8. So remember, it's multiple choice, so I probably will give you 12.8. I might give you it if you put x on top. I might give you it in multiple ways. But for that one, it's simply just 12.8. Let's start to the next one, 7.7, which is the inverse. So this time I'm finding the angle when I'm given two sides. Again, it's always a right triangle. So let's call this 10, or let's call this 13, and I want to find this angle right here. Now, how am I going to do it? Go back to SOHCAHTOA and let's set it up. SOHCAHTOA, and let's see if we can set it up. So opposite hypotenuse, we don't got that. Adjacent hypotenuse, we got the adjacent, we got the hypotenuse, we're good to go. So cosine of theta equals 10 over 13. Well, that means 10 over 13 is that we want to get this cosine all by itself. I think I said 10 earlier. Just think of this cosine. I want to get this cosine all by itself. So how am I going to do that? Well, cosine of theta, 10 over 13. I can't just divide cosine out, so I have to use inverse cosine. Cosine of -1, so I can separate these two. And then I'm going to put cosine -1 here. So theta equals cosine of -1, 10 over 13. And that you literally just have to slap into your calculator. So cosine of -1, 10 over 13. That should give you around 39.7. So theta should equal 39.7. So you just have to identify which one you're using, sine, cosine, or tangent, and then you just have to find the inverse. 7.7, now we're on to 7. Is there 7.8 in this one? No, so let's go to 8.1. This is angles and polygons. So angles and polygons. So there's like couple of things you need to know. First off, you need to figure out what the sum of all the angles are. So let's say if I had a 1, 2, 3, 4, 5, 6. I had a 6-sided hexagon. and I want to figure out what these 6 angles add up to. Well, I just simply plug it into the equation. S equals 180 times n minus 2. S is going to be the sum of all the angles, and n is how many sides there are. How many sides there are is equal to how many angles. So how many angles there are. So this is a 6-sided shape. So S equals 180 times 6 minus 2. That's 4 times 180 equals S. And 180 times 4 is going to be 720 equals S. So all the angles add up to 720. So since all the angles add up to 720, that makes it pretty fair game / simple. Now I could ask another type of problem from this. Tell me if this is a regular hexagon, and a regular any type of polygon, it's just mean all these are equal. What would one angle of the regular hexagon add up to? Or what would one angle be if all these angles were equal? Well, we know what the total is, 720. So to find just one angle of the 6, you would just divide it by how many sides there are, which is 6. And 720 divided by 6 should be 120 degrees. So each angle here is 120 degrees. And let's just check that. 120 plus 120 plus 120 plus 120 plus 120 plus 120, 240, 360, 480, 600, 720. So that makes sense. It should add up to 720. So I could ask you what is one angle worth, and that's 120 degrees. I also could ask you if I have a 11-sided shape, or polygon I should say. I could just tell you in words, like 11-sided polygon. I could just ask you that. I don't have to draw the shape every time. But I could give you the reverse. I have a shape that's 1,800 degrees. It's the sum of the angles. So how many sides does it have? So in order to figure out that, all I have to do is plug it into the equation and work a little backwards. So you have to do a little algebra with this. So the equation was sum of angles equals 180 times n minus 2. So that's 1,800 equals 180 times n minus 2. Well, I'm going to divide 180 on both sides. Cross that out. That's going to be 10 equals n minus 2 plus 2 plus 2. This is a 12-sided shape. Okay. So that's a 12-sided shape. That's pretty basic. One other thing I could definitely ask you is the exterior angles. 2 parts of the exterior angles at least. One is, what does the sum of a 210-sided polygon, so 210-agon, what is the sum of the exterior angles? Well, the answer is always going to be 360 degrees. The sum is always 360 degrees for an exterior angle of a polygon. No matter how many sides, from 3 to 210 degrees, it's going to be 360 degrees. Now I could ask you something like, at a hexagon, which is 6 shapes, or 6 sides, what is one exterior angle? And I'm not just a hexagon, I have to tell you it's a regular hexagon. A regular just means that they're all equal. All the angles are equal and all the sides are equal. A regular hexagon, what is one exterior angle? So one exterior angle for a regular hexagon, so we know automatically that the outside has to add up to 360. And if I just want 1 out of 6 of them, I would just divide it by 6. So each angle should be 60 degrees. So the exterior angle of the hexagon should be 60 degrees, like one angle of it. Let's move on. Let's go to 8.2, properties of parallelograms. So this is pretty basic. We're going to make a parallelogram here. There's a couple things you need to know about a parallelogram. One, these two sides are parallel, and these two sides are parallel to each other. These are the little triangles that represents parallel. Another thing you need to know about a parallelogram, that is not. This side should equal this side should equal this side. So the opposite sides equal. And the last thing you should know about parallelogram is that, the opposite angles are equal to each other. So you need to know that. Now, I could give you either in a sentence or as a picture. Let's do it as a picture. A, B, C, D. If this is 60, what would this have to be? Well, that should be pretty obvious. This has to be 60 also. If this was 17, what would this have to be? Pretty obvious, 17. If this is 25, no, if this was 125, what would angle C have to be? Well, these two are equal to each other, so that's 125. Now, what would angle B equal to? That's a little different, or angle D. Well, I know the whole thing is 360, which leads me to believe that 1/2, and this is a parallelogram, so I could do this, cut it in half, and have this equal to 180. So to find angle, let's say D, I would just do 180 minus 125 equals angle D, which is going to be 55. So this angle is 55, and we know these two have to be equal, it's 55. And it also makes sense because this adds up to 180, like vertically here. This adds up to 180, vertically here. This add up to 180, this add up to 180. So they all add up to 180, which is good. And the whole thing together adds up to 360. Just looking through, I don't see much. Oh, one more thing about parallelograms is that the diagonals of a parallelogram. You draw the diagonals of a parallelogram. These two pieces of the diagonal, like the thing, is cut in half. So this one and this one. So let me just put some letters so I don't just keep saying this one and this one. Let's put this as E. So AE to EC are equal to each other. Also, ED to EB is equal to each other. Because it's, let's say for a fact it's a parallelogram, you know that's true. And I could just do the same type of problems here. If this is 60, this has to be 60. If this is 60 and this is x plus 20, then x would be 40. Not much to do there, nothing special. Why don't we go to 8.3? Show that it is a parallelogram. To show that it is a parallelogram, you have to prove one of these things, where these two pairs are parallel to each other, while these two things are equal to each other, while these two angles are equal to each other, or that these two diagonals are equal to each other. So a question to kind of just go over that could be something along the line is, I can ask like, what shape is this? And it might look like a parallelogram, but you can't confirm it's a parallelogram. So I either have to tell you this is 60 degrees and this is 60 degrees and this is 120 degrees and 120 degrees. That is enough information to be a parallelogram. Even if I covered up one of these angles, that will still be enough information. Because let's say you didn't know this one, or I didn't tell you this is 120. You could find out by doing 120 plus 60 and subtracting it from 360, which is the sum of the interior angles. What else can I show you? So you either have to prove that one way or the other. Or I could ask you one of the algebra questions like, if this is x plus 3, and this is like 10, what x makes this a parallelogram? And this is 13 and 13. What x makes this a parallelogram? Well, x plus 3 equals 10 minus 3 minus 3. X has to equal 7. Something like that. 8.3 is not too different from 8.2. I feel like I remember talking about that while we were learning that section. Oh, okay. So 8.4, properties of rectangles, rhombuses, and squares. So let's first understand what a rhombus is. A rhombus is where all the sides are equal. Think of it as a slanted square. A rectangle is where all the angles are equal. Since it's a rectangle and all the angles have to be equal, the angles are always one thing, 90 degrees. And a square is just a mixed match of both of them, where both the sides are equal to each other, all 4, and all angles are equal to each other, all 4. Now, these are all parallelograms. So for a rhombus here, this and this are equal to each other, these diagonals, and this are equal to each other. So the diagonals are still equal to each other, but not all 4 of them are equal. Over here again, this and this are equal to each other. These two and this one and this one, the side ones, are equal to each other, but not all 4 are equal to each other. The only time that applies is a square. Put good money down that I will ask you a question like this. Is a rectangle a square? And you're going to put option A, always. Option B, sometimes. Or option C, never. Well, if it's a rectangle or a square, well, a rectangle is not always a square. It could sometimes be a square. A rectangle where the sides were 5, 5, 5, 5, that would also happen to be a square. So sometimes it's a square. Is a square a rhombus? I won't write the options out again. Well, a square by definition has 4 sides equal. So in order to be a square, it has to have all 4 sides equal. And to be a rhombus, it has to be 4 sides equal. Since that's always true for a square, that means it's always a rhombus. So this one's always. Is a rhombus a parallelogram? This whole section, these are special parallelograms. So by definition, it is a parallelogram. A rhombus is a parallelogram, a rectangle is a parallelogram, a square is a parallelogram. So always a parallelogram. Is a trapezoid a square? No, That can never actually happen. A trapezoid, by definition, needs two sides different from each other. And they have to have, by definition, also two sides are non-parallel. So it's just impossible for it to be a square and a trapezoid at the same time. So that's a never. That's 8.4. Also, of course, I could do the same thing like before on the other questions. If this is 8 and this is x plus 3, and you know it's a rectangle, what is x? Well, x is going to be 5. It's pretty straightforward. 8.6 or 8.5, let me just check what that is. Properties of trapezoids and kites. So what did we talk about trapezoids? So for a trapezoid, so this is 8.5. So for a trapezoid, it's going to be something like this. One key thing is, if I tell you it's an isosceles trapezoid, that means these two sides are equal. And if it's also a isosceles trapezoid, that means these angles are equal to each other, and these two angles are equal to each other. You still kind of could do the thing with parallelograms. It doesn't work all four ways, but you could do that these two add up to 180 and these two add up to 180. Just a key note, the top ones do not add up to 180 and the bottom ones do not add up to 180. You can't do it like the other one, like in the parallelogram. Only the sides. And for all trapezoids, not just isosceles, these are parallel. Another point is, if you know these two angles are equal to each other, whether here or here, you automatically know these two sides are equal to each other. The reverse is true. If you know these two sides are equal, you know these two angles have to be equal. You know these angles have to be equal and this angle has to be equal. Also, in terms of its diagonals, let me put A, B, C, D. If you have a diagonal like this and a diagonal like this, AC equals BD. So you remember in parallelograms, and I'll just redraw here, the pieces of the diagonal are equal to each other. But these two diagonals are, as a total, is not necessarily equal to each other. But this one, AC equals BD. This one is the whole line is equal to the other diagonal line. So the whole line equals the other diagonal line. These two pieces are not necessarily equal to each other, but this whole line equals this whole line. Well, let's just do a practice problem. So this trapezoid, and I'll get to kites next. Oh, also, this problem, which most of you guys could do quickly. If you have this in the middle, so like let's say, you know, these two are equal and these two are equal, and then let's say this is 8 and since this is 12, the middle line will be the average between the two bases. So 8 plus 12 over 2, that's 20 over 2, which is 10. So you know the length of the middle is 10. So, and of course, all these things work in reverse too. If you know this is 8, 10, 12, then you're forced to know that these two lines are equal to each other. And these two little segments are equal to each other. So it works in reverse also. What else do I need to do for this? So that's trapezoids. Let me just give a trapezoid question other than that geometric mean one, or the mean one. If you know these two angles are equal, and this is x, and this is x, 5 minus x, and this is 2. What is x? Well, because I know these two angles are equal, I know these two sides are equal. So 5 minus x equals 2, plus x plus x. You could do it the other way around where you move 5 and divide by -1. it doesn't matter. Phi, excuse me, equals 2 plus x minus 2 minus 2, 3 equals x. That's the basis of it. For kites, what do you need to know about kites? What I would particularly know about kites, at least what I've practiced you guys with before, is that this angle and this angle is the same. Just know that these two are here and that these two are equal. To make it a kite, this has to happen, and these two angles are opposite or equal. So my question probably would be involving something like this. If this angle is 10x minus 1, and then this angle is 89, what is x? Again, set it equal to each other. Notice that a lot of this in geometry is just setting things equal to each other. We'll get to the problems where you got to set things half to each other or double each other. That happens too. Plus 1, that's 90 equals 10x. Divide by 10, divide by 10. X equals 9. Not much more to do from that section, so let's move on. Did we do 8.6? We did a little bit of 8.6. This is just basically identifying things, which you kind of already do in the problems. In terms of the final, I even ask you that. These are typically like true-false questions. For example, is a rhombus I forgot what was it before. Is a rhombus a quadrilateral? Just remember, a quadrilateral is a four-sided polygon. So is rhombus a four-sided polygon? Yes, that's true. Okay? These would be more true or false questions. The other ones might be I could give you both, either always, sometimes, never, or true or false. So just be prepared for both type of questions. There's a very fancy chart that I'll post later on Google Classroom that kind of like does the family tree of all these things. So it kind of shows you like the connections. So that is 8.6. It's not much to talk about. It's kind of more like true, false. Do you know what a rectangle is? Do you know what the difference between a rectangle and a rhombus is? But we kind of already do that along the way. So that's why I don't really spend time on that. Let's go on to our next one. We're on the circles, which is good. So that's chapter what? Chapter 9, I guess. Let me look. Chapter 9 we'll do at the end because that's what we were doing at the end of our thing. So let's go back to chapter 10. Let's go to chapter 10. Because chapter 10 is the circles, and I just kind of want to be more chronological order of this. So a couple of vocab words with the circles you should know by studying. If you have a line that goes through the edge and that's not in the center, that's a chord. If it goes through the center, it's a diameter. And if it goes straight through the circle, like to the outside, that's a secant. And if it only hits the circle once at the tip, or at one exact point, that's a tangent. And remember, half a diameter is a radius. Is there anything else from here? Tangent, radius, chord. And the center is always the center. It's just the point in the middle. Okay. Let's just check something. All right, so make sure you know those vocab words. I'm going to ask like something probably along the lines of, what's a line that hits two parts of the circle, doesn't go through, and or what's a line inside the circle that doesn't hit the center? Well, that's a chord. What's a line that only hits the circle exactly once on its edge? That's a tangent. What's a line that goes from the center to the edge? Just from the center to the edge? That's a radius. What's a line that goes through the edges of the circle? That's a secant. So there's a bunch of ways I could just ask that question. Kind of vocabulary, nothing much to work about there. Also, one more vocab. Two circles together. Two circles could have common tangents. So this would be one pair of common tangents. That's 1, 2. You can have one on top, which is 3, and one on the bottom, which is 4. So that's 4 common tangents. If the two circles were exactly touching each other at one point, there's one right in the middle, and then one top and bottom. So that's 3. If they overlap like a Venn diagram, that's 2, because they only have the top and the bottom. If one circle's on the inside of the other circle, but they share, like he's on the tip of the outside, that's 1, because it's the one thing that could touch both circles without going into it. And if it's completely submerged in the circle, as in it doesn't touch the tip, that's 0. So common tangents, how many are there? Make sure you know that question. That should be a freebie. Let's see. What else we got? Oh, okay. I kind of forgot about these. All right, so in 8.1, we also have those like triangles in the circle. They're those like special angles or something like this. So let's say you have a big circle like this. Looks like an egg. Let's call this up here. I'm going to give it, let's see what number it is. I'm just looking at the book. Let's call this one 3. And we're going to go this way and down this way. And let's call this one X. And let's call this one 3 and 2. So if this is 3 and this is 2, the whole line is going to be 5. The whole line is going to be 5. It's not a divide, by the way. It's just showing that I'm talking about the whole line. What is X? Again, you need to know the Pythagorean theorem. 3 squared plus x squared equals 5 squared. 9 plus x squared equals 25. You've probably seen this example a million of times, so it should be no surprise anymore. X squared equals 16. Square root of 16 is 4. And we only take the positive 4 because we're talking about distance. So x equals 4. This is contingent on me telling you this line on top, let's say AB, is a tangent to the circle C, or I show you that this is a right angle. Again, to do SOHCAHTOA or to do common tangent or to do a right angle, it has to be a tangent. Or I have to show you something. Either it's a right angle or I tell you it's a tangent. To do Pythagorean theorem, I was going to say, you need to be a right angle. Is there another way I could tell the problem? Oh, I could do this one too. So let's do another circle. Right here. Let's call this one line here. Let's make this line over here. And let's make this line here. Does this one require factoring? No. Well, let's call this R. Let's call this R. Let's call this, what is this? I don't know. Let's try it. 6. And let's call this long side 9. I'm going to be A, B, C. I'm getting this question from your textbook, by the way. So let's find what let's find what R is for this one. So in order to do this, we're going to have to set this up. R squared plus 9 squared equals, now this whole line is R plus 6 squared. You got to make sure you put it in parentheses and the square is on the inside. So you have r squared plus 9 squared equals r plus 6 squared. That's the same thing as r plus 6 times r plus 6. This requires foiling. Foiling is fair game on this test. What's not fair game is factoring. I won't be testing on factoring. But foiling is a fair game question. So r squared plus, I'll just do it out, 81 equals, I'm going to FOIL it really quickly, r squared plus 12r plus 36. What's really convenient, and always will happen honestly on these type of questions, r squared and r squared, I can minus r squared here, minus r squared here, these two cancel out. So now we just have 81 equals 12r plus 36. Now our question has been reduced to a two-step problem. Minus 36, minus 36. 81 minus 36 should be 75, 45 equals 12r. Yeah. And then divided by 12, divided by 12. 45 divided by 12 is going to be, let me just draw this here. Yes, Jeremy, this video will be on the YouTube later. So I'll post it again when it's finished. So 45 over 12, that's going to be 3.75. So r is 3.75, no problem, Jeremy. 3.75, r is 3.75, we found our answer. Let's see, what's next? 10.2, arc measures. This is not too bad, actually. This one, I remember some people got confused. If you got this circle in the middle right here, and your center is right here, and you have your angle, these two angles will equal to each other. So if this is 30 degrees, this also has to be 30 degrees. Another type of problem. This is x plus 3, and I'll call this one 12 degrees. So you set the equal to the other, 12 equals x plus 3, minus 3, minus 3, 9 equals x. These problems I'm getting from is just from the textbook from the review sheet I handed out the other day, which is attached to the Google post that this video is linked on. Let's see. I'm trying to see what kind of questions I could ask. So a question I could definitely ask is like, let's go this A, let's go this C, and let's go this D, or B. Let's go to center C, or D. If this is 80 degrees, and you know BC is a diameter, what would angle AC have to be? Well, a diameter is always 180 degrees, or a semicircle. So 100 minus 180, or 180, I should say, minus 80, is going to give me 100. So this one's 100 degrees. I can also ask, what is arc BCA? So pay attention what order the letters are. So since I asked for BCA, I'm going from here to, let me just wiggle it, here to here. So I'm going from B all the way to A. So we know this is 80, we know this is 100. Just to remind, a full circle is 360, so this has to be 180. And remember, since this is from the center of the circle, this has to be 180 degrees, this has to be 100 degrees, this has to be 80 degrees. So if I just want B to A passing C, 180 plus 100 is going to be 280 degrees. Again, I won't go through every type of problem, but I might go through a type of problem. 10.3. This is applying things about chords. Here's the thing you need to know about chords. If I tell you this line is equal to this line, then you know this arc is equal to this arc. So example problem may be something like this. If this line's 9 and this line's 9, and this arc is x plus 22, and this is like 100, what would x be? Again, just set it equal to each other. X plus 22 equals 100. Minus 22 on both sides. X equals 78. Again, a lot of things to geometry is simply setting equal to each other. Other thing you should know about chords, if you know, let me just draw like a thing like this. If this is perpendicular and it's going through the center, then you know these two lines are equal to each other. Let me just do a problem like that. This is 4x, and this is 3x plus 7. Now, I didn't tell you explicitly that they're equal to each other, but you should know 4x plus 3x plus 7 because of this right angle and it goes through the center. So 4x equals 3x plus 7 minus 3x minus 3x. X equals 7. That's the 10.3. 10.4. Described angles and polygons. This was one of the harder things I noticed for you guys, and this is the thing you got confused with 10.1. This is where the angle is on the edge of it, so like here. So if this angle here was 80 degrees, this arc is going to be double it, which is 160 degrees. So if that angle's 80 degrees, the arc is going to be 160 degrees. And some problems I could simply ask is like, if this is, let's do it again. This is x, and this is 210. That's going to be 210 divided by 2 equals x. So that's going to be 105 equals x. In multiple ways, I can set that up too. Also, if two described angles have the same opening, so like, let me just put letters A, B, C. Let's use this one. This is D. So angle ABC has to be equal to angle ADC. Because they share the same opening right here, these two angles. So angle ADC and ABC. See how this works. So angle ABC and angle ADC, because they share the same opening, they have to be equal to each other. I've done enough equal to each other problems, so not much to talk about there. What else? I think that's pretty much what you need. 10.5, this is the one with like the two relationships between each other. So let's see. So 10.5 is going to be, the three relationships here are, oh shoot, this angle and this arc is going to be doubled again. So if this is 20 degrees, this has to be 40 degrees. Also applies to here. If this is 160 degrees, this has to be 200 and 320 degrees. And notice the full circle makes 360. This one type of circle, we're gonna go like this. This is not in the center. Notice that this is not in the center, so you can't assume that it's just equal to the arc. And with that in mind, it's going to be if I said this one is 130, let's use the other side. Let's do 130 degrees, and this is like 156 degrees. What would this angle be right here? I call it angle A. Well, what you're gonna do is find the average. So 156 plus 130 divided by 2. That is going to be 143. That's 143. Yeah, because you're going to do 156 plus 130, which is going to be 286, and then divide by 2 is 143. Yeah, that's correct. So angle A is 143, and the angle below it, because they're vertical angles, is 143 also. Is there anything else? Oh, and the last one, when you have a circle like this, where you have the angle on the outside of it, that means that you would take this outside arc minus this inside arc to get you the angle here. So it makes this 100, it makes this 60, and you would divide it by 2. So let's do that. So 100 minus 60 divided by 2 is going to be 40 divided by 2, which is 20 degrees. Which is 20 degrees. That's the end of 10.5. 10.6. It's going to be this huge circle, and you're going to have two lines in it, and you got to find the segments of the lines. So let me put A, B, C, D, E. Notice this line is not in the center. So how do you do it? It's going to be AE times ED equals BE times EC. Example, this is 8, this is 6, this is 2, this should be x. So 8 times 6 equals 2 times x. 8 times 6 is 48 equals 2x. Divided by 2, divided by 2. 24 equals x. So x should equal 24. The other ones, there's two more, isn't there not? Oh yeah, these. So these could become foiling, or foiling's okay, but these will, they have promised it will not be factoring because I didn't even give that on your little tests. A, B, C, D, E. This one is CB times CA. So notice it's the whole length equals CD times CE. So if this one's, let's do this. 5, 4, 3, and let's call this one 3, and this one x. Let's see how that works out. CB is 5 times 5 plus 4, which is 9, equals 3 times 3 plus x. We don't know what that is, so we're going to have to write that as 3 plus x. So 5 times 9 is 45, equals 3. We're going to distribute. Distribute is fair game. 9 plus 3x minus 9 minus 9. Okay. Minus 9 minus 9, that's going to be 45 minus 9 is 36, equals 3x divided by 3 divided by 3. X equals 12. Yep. And then the last one, this is, I don't think, or this one is not too big. This is when it's like a tangent along with a secant. Something like this. Whatever. Let me call this A, B, C, D. When you know this one is because it stops here. So AB squared, line squared, equals BC times BD. Example, and I would not do a factoring one, so let me just make one up real quick. We'll call it BA8. We'll call this BC4, and we'll call this X. So let's see, set it up. AB, so that's 8 squared, equals 4 times 4 plus X. So that's 64 equals 16 plus 4X minus 16 on both sides. That is going to be 48 equals 4x divided by 4 divided by 4. X equals 12. Ironic that it equals the same. So that's 10.7. No. Did we do 10.7? No. So let's go to 11. This is the area thing. The area, with the area, it's just following equations, so you have to be able to identify the equations and find them. So with that in mind, let's see what we could do with that. You're gonna get the equations, and I'll give you that on Tuesday. So let's just do this quick one. 8, 6, what's the area? 8 times 6, if this is a rectangle. 8 times 6, which is 48. And there's a bunch of area problems. I don't want to do them right now because I feel like they're too straightforward. But I do want to do 11.1, which is the circumference. That's C equals 2 pi r. So with circumference being 2 pi r, let's see what we could do. Circumference equals 2 times 3.14 times, let me give you a circle. And the r is 5. So 5. So it's going to be C equals 10, so that'd be 31.4. That's pretty easy. What's a little bit tougher is that when you have a segment. So let's say, or this is called the arc length. So let's say if this was 45 degrees over here, and this thing is 45 degrees. I want the actual length, so how long this is. And I told you the radius was, let's make it 5 again. So in order to find the arc length, you just have to do your angle, let's call this AB. The arc of AB over 360 times the formula circumference, which is 2 pi r. So this is just 45 over 360 times 2 times 3.14 times, we know what r is, which is 5. That's going to be that's end up going to be 3.925 equals the arc length. So that's 10.1 right there. 10.2, almost the same thing, it's just now area. So our circle, so if this thing is, let's call it 5 again, just so we know it's not the same thing. Its area equals pi r squared. So area equals 3.14 times 5 squared, which is 25. 25 times 3.14 equals 78.5. And again, I could just give you a piece of the circle, so I want to know from 45 degrees. So this is 45 degrees. How much is this shaded area right here? And I told you this is 5. Kind of the same thing. This is called a sector, or a shaded area of the circle. This is, again, almost the same thing as above. AB, arc AB over 360 times pi r squared. So that is going to be the same thing as 45 over 360 times 3.14 times 5 squared. If you get that, that should be 9.81 if I were to stop there. So your answer should be 9.81 for the sector. That was, did I say 10? I'm sorry. This should be 11.1, and this is 11.2. Apologies for that. 11.3, area of the regular polygons. These are made to be a lot harder than they look, but they're not actually that hard. So we gotta remember that weird new word we learned, which was asymptote. So this is a pentagon. Here's the center of the pentagon. This is a regular pentagon, I should say. Your asymptote over here, let's say it's 6, and one of your sides is 10, and I told you it's a regular one, so you know all these are 10. How can you find the area? Well, we're gonna make this like an imaginary triangle over here and do 6 times 10 to find the area of one triangle. So 6 times 10 divided by 2. And then how many triangles can we make? Since this is a 5-sided shape, we can make 5 triangles. So I'm going to times it by 5 at the end. So 6 times 10 divided by 2 is 30 times 5. 30 times 5 is 150. So the area for this thing is 150. 10.3. A lot easier than I made it the first time around. Is there anything else from here? Oh, what would the interior angle be? So let's say this is let's make a hex, let's make an octagon this time. Octagon, 8-sided. So I have my center point here. And let's say I want to go here to here. So that's A, B, C, D, E, F, G, H. So from A to C, I want to know how big this angle is. Well, first I count how many sides I have selected. So I have AB and BC, so that's 2 sides. How many sides are there total? There's 8 sides in total. And what makes a full rounded circle? This should be brought back 360 degrees. So that's going to be 2 over 8 over 1 over 360. I could reduce this to 4, and this is 180. I can reduce this to 2, and this is 90. I can reduce this to 1, and this is 45. And then 45 times 2 should be 90. So the answer is 90 degrees for that one. If I asked for one of them, it would have been like 45 degrees. If I asked for 3 of them, you figure it out. Always the top part is what you selected, the bottom part is the total. Well, I'll do 11.4. I said 10.3 again, I'm sorry, 11.3. 11.4, geometric probability. This is pretty simple, but let me just do it. This kind of also reviews some of the shaded area thing. So let's say this, and let's say this is shaded. Let's call this 6, let's call this 3, and let's call this 13. What's the chances of me selecting the random shaded area? First, I need to find how big the shaded area is. In order to do that, since it's a shaded area, I need to first find the whole side. So this is a 13 by, what's 6 plus 3 happens to be 9. So 13 times 9 equals 90 plus 27, 117. Yeah, 117. And then 117 is the whole thing. I want to find the small piece now, the shaded piece that I want to figure out. Or actually, oh no, I had enough information actually. I could have just found 13 times 3. I made a mistake. I could have gave you this much information. You would have found it all normally. But either way, 13 times 3. Let me find it as if I didn't know. So I need to find 13 times 6, which equals 78. And I would subtract the 2 of them. So 117 minus 78 equals 39. So 39. So this is 39, so the shaded area is 39. Now, to find the probability of me randomly landing, like throwing a dart and randomly landing there, it's going to be 39, the shaded area, over the total thing, which is, we found earlier, 117. 39 divided by 117 equals 1/3. In a multiple choice question, if I give you like I would not put 0.33 repeating, I would just put 1/3 if it was a multiple choice question, which it could be. Okay, 11.6, volumes of solids. So this is where we have like a base and the the 3D height. So I'll just do a cylinder for this one. Let's make the radius 5, and let's make the height 7, the height of the 3D shape. So for any volume question, is volume equals the area times the height, and capital H height. That's because we're talking about the height of the 3D shape. So this is a circle base, or a cylinder, so that's going to be pi r squared times the height. And we actually know what the height, we already know all the numbers. So 3.14 times 5 squared times 7. When you slap that into the calculator, your volume is going to be 549.5. And there's a bunch of other shapes I could do it with, if a triangle was the base, if a circle was the base. So there's a bunch of ways I could do it. 11.6, 11.7 is pyramid, or cone, if it's a circular base. So with pyramids or cones, I have to give you the base again. And I know a lot of you complain, or say, I should say, not complain, that it's hard to differentiate between a pyramid and a cone. I'm not hand drawing these, they're going to be computer made, so it should be pretty clear which one is a pyramid and which one is a drone. So right here is a right angle, This right angle is going to the top of the pyramid. I'm going to say this right angled pyramid is going to be like the height of 8. I'm going to say this side of the triangle, this base is going to be 6. And I'm going to say this side is like, I don't know, 14. So again, volume for a pyramid shape is going to be area times height, all divided by 3. Think of it as it's 3D, so I got to divide by 3. So this is a rectangle base, so that's going to be 6 times 14 times 8 over 3. I can reduce this to 1, I can reduce this to 2. So that's 2 times 14 times 8 equals 224. Again, different bases, different problems. 11.8 was... spheres. So surface area volume. So a sphere is this 3D circle. So if I gave you the radius of the sphere is like, now let's change the number this time, 9. No, 9 makes it so they're equal to each other. Let's make it 10. The volume, the area, the formula for the surface area, and I'll give you this on the test on the reference sheet, is 4 pi r squared. So you just plug it in, literally nothing to do. 4 times 3.14 times 10 squared. That's going to be surface area is going to be 1256 equals S. For the volume of a sphere, it's very specific. It's going to be 4 over 3 times pi times r cubed. So volume equals 4. I could just put this all over 3 times 3.14 times 10 cubed. So 4 times 3.14 times 10 cubed divided by 3. So that's going to be a volume of 4,186.67. I might give it as 4,186 and 2/3. That could also happen. And if I find the circumference, it's the same thing as finding the circumference of a circle. Your book does not get chapter 12, right? Your book has chapter 12, but for some reason it does not have it as in the back. That's pretty interesting. Chapter 12, did we do anything in chapter 12? No, I don't think we did. I gotta check the review sheet later. I'll check now, actually. Oh. 'Did I put chapter 12 into us? No, I didn't. Okay. We did get some chapter 9 down, though, so let's get some chapter 9 in. Because we had a little extra time. So 9.1. Go back here. So 9.1 was translate. This is super basic. If I give you, let's say, 3, 4, and tell you to change it x plus 3, y minus 2, you simply just do it for each position. So 3 plus 3, this one's going to be 6, and 4 minus 2, this is going to be 2. The first thing you get is your pre-image. The second thing you get is your image. And the motion of it is called a transformation, so how it changed. Another way I could write it as a vector form. So this is like 8, comma, -3. So that means do x plus 8, x minus 3. Is there much to do here? No, that's not much. 9.2, matrices. So what's interesting about matrices is if you add them, it's super easy. They have to be the same exact size. And you add based off position. So this is, let's say, I'll just make it a 2 by 1. Or, yeah, a 2 by 1. 8, 3. Let's make this -5, 12. So they have to mate. So 8 plus -5, so it's going to be the same size too. 8 plus -5 is 3. 3 plus 12 is 15. Another thing you do is multiply. Now, for multiplying, it's a couple of steps, but it's not too bad. So let's do 3, 6, -1, 2. Let's do 0, 5, 8, 3. I'm going to call this row 1, row 2. I'm going to call this column 1, column 2. That'll come later important. So this is a 2 by 2, and this is a 2 by 2. So first, let's check if that works. Since these two are in the middle equal, so that's okay, it works. And your new answer is going to be a 2 by 2. So I can just pre-draw that. 1, 2, 3, 4. And I'll call this row 1, row 2, column 1, column 2. So I want to multiply row 1 with column 1 first. So how do I do that? So the first position of row 1 multiplies with the first position of row 2, or column 1. So 3 times 0 plus the second position of row 1 multiplies with the second position of row 2. 6 times 8. Well, 3 times 0 is 0. Plus 6 times 8, which is 48. So for row 1, column 1, it has to be 48. Let's circle vertically. Let's do the next one. 3 times 5. First position of row 1 with the first position of column 1. So that's going to be 3 times 5 plus 6 times 3. 15 plus 18, that is going to be 20, 33. Now row 2, column 1. So it's going to go row 2, column 1. -1 times 0 is 0. 2 times 8 is 16. -1 times -1 times 5 is going to be -5. And 2 times 3 is going to be 6. So it is going to be just 1. So your answer right here is 48, 33, 16, 1. Just remember, these two middle ones have to match. If they don't match, you cannot multiply it. I think this is the tail end. This should be the last one, 9.3. Oh no, we got rotations too. 9.3 is reflections. Where is that? Reflections. So what are reflections? Essentially, if I told you, please reflect let's say this rectangle right here, or square, I guess, over the x-axis, how would I do it? So there's specific rules. If you're flipping over the x-axis, it's AB being the original, or the pre-image, is going to be, if you're flipping over the x-axis, so you're going this way, okay? You're going over this way. So that means if this is AB, then this has to be A negative B. If you flip over the y-axis, so you're flipping over this line, this way, so it's going to be flipped like that. That's AB is going to be negative a comma b. If you're flipping over line xy, so line xy is this line over here, or x equals y, I should say. So you're flipping over x equals y. So you're flipping like diagonally over, like from here to here. That's AB. That is going to become simply BA. If you're reflecting over y equals negative x, that's AB going to be negative b over negative a. Negative, y equals negative x is just the reverse, or I guess the perpendicular of this one. So you flip over here. And then usually I just ask you a problem like flip a of 3 comma 5, let's say negative 5, over x equals y. Well, 3 comma negative 5 will become, this is the image, negative 5 comma 3. Pre-image, image. That's a reflection. 9.4 over here, the last itty bitty piece of it is going to be reflections. Oh no, rotations, my bad. So what exactly is a rotation before I just move on? A rotation is, let's say I have a shape here. I want to rotate it. So it starts here, and I'll rotate it this way, or rotate it this way, or rotate it this way. I'm just going to go quick and tell you what the special rotations are. If you're doing 90 degrees, AB becomes negative B comma A. If it's 180 degrees, AB, B becomes negative A comma negative B. 270 degrees equals AB becomes B comma negative A. That's not much I'm going to do here. I'm just going to really just write the problems like this and say something like reflect, or no, rotate 4 comma negative 3 over 270 degrees. So 4 comma negative 3 will become negative 3 comma negative 4. That should be everything on your final. I didn't expect me to take this long. What is this, like an hour and a half? Yeah, so hopefully you use this video to help you just understand everything you're missing. If you look at this video, I recommend just putting it in the background. Maybe do some studying and then have this on the side. Just to help you like, oh yeah, this kind of question might happen. Again, I did not go over every type of question. Again, this is just the concept thing, and I'm just doing a little bit of everything. The main purpose of this is just so you have something to watch and help press out some of the very basic questions and more focus on like, oh, I didn't really understand what you did in 7.8 or 7.7, Mr. Tobel. Can you do it again? Then I'm happy to answer that, especially if you checked out the video. For anybody who popped in, thank you for coming in. Sorry it was boring, but otherwise, I hope you guys enjoyed the video. I hope you use it well. And I hope you are studying for the final because I want you guys to do well and I want you guys to succeed. That's why I make these videos. Otherwise, I'm very tired now, so if you have any questions, you can still shoot me an email. I'll be delayed in responding to it. Yeah. That's it. All right.